All right, so now we are going to move on to the last section of Chapter 3, and that is Section 8. In Section 8, we're going to talk about parallel and perpendicular lines, and I'm going to break this up into two separate videos. So one video will be just parallel lines, and then the other video will be perpendicular. So the first thing that we're going to talk about are slopes of parallel lines. All right, and if two non-vertical lines are parallel, then their slopes are equal. Right, so one of the things that you have to remember is you have to remember that parallel lines have the same slope. Right, so parallel lines have the same slope. If the slopes of two distinct non-vertical lines are equal, then the lines are parallel. So one of the ways, if I tell you that lines are parallel, then we know right away that their slopes are equal. And then if we go and we solve for the slopes and we see that the slopes are equal, then we can then say that means that the lines have to be parallel. All right, so we're going to use both of these in the two examples that we're going to do. We're going to do use both of these in our two examples. All right, and then the last thing is if two lines are both vertical or if they're both horizontal, then they are parallel. All right, so if we have two lines that are vertical, then we know that they are parallel. And then if we have two lines that are horizontal, then we also know that they are parallel as well. All right, and we know that because our horizontal lines will both have a slope of 0 and our vertical lines will both have a slope of undefined. All right, so let's go through the first example. So the first example here is to determine, are the lines parallel? All right, so if we want to know if these lines are parallel, we need to solve for the slope. And we know that the slopes are equal to our y2 minus our y1 over top of our x2 minus x1. Neither of these lines are vertical or horizontal, so we have to go ahead and we have to solve for the slope. So let's talk about line 1 first. All right, so line 1, we have the points of -1, 5, and we have the points of 2, -4. So it doesn't matter which ones you label x1, y1, we'll just say x1, y1, and x2, y2, and then we plug it into the formula. So our slope is equal to our -4, or y2 minus y1, which is 5, over top of our x2, which is 2, minus our x1, which is -1. So this will then turn to plus. So then our slope is equal to -9/3, or our slope is equal to -3. All right, so that's the slope for our line 1. So then if we want to see if it's the same slope or see if the lines are parallel, we have to find the slope of our line 2. Well, the 2 points for our line 2 are -3, 3, and -1, -4. So same thing, we need to label these x1, y1, and x2, y2, and then we plug it into the formula, y2 minus y1 over x2 minus x1, so it's -4 minus 3 over top of -1 minus -3. This will turn to plus, so then our slope is equal to -7 over top of 2, and since this slope does not, since -7 over 2 does not equal -3, we can say that line 1 and line 2 are not parallel. All right, if they gave us the same slope, then we would say that they are parallel, but since they gave us -7 over 2 and -3, they do not equal each other. All right, so then the last example we're going to do is we're going to be asked to solve for an equation of a line that is parallel to a given line. So now we know that they're parallel. So in order for us to find an equation of a line that's parallel to it, we would need to plug into one of two formulas. I'm going to want you guys to write it in our slope-intercept formula. So I want you guys to end your equation like this. All right, so in order for us to go ahead and find this, we need to solve for our slope and we need to solve for our y-intercept. Well, we know our slope right away because it tells us that our lines are parallel, so that means that this new line or this new equation has to have the same slope. So I know that my m is also equal to -3. So right away I know that y is equal to -3x, and then the last thing I need to do is solve for that b. Well, just like we did in the last section, if we want to solve for that b, we have an x and we have a y. We can plug them into our equation. So we can then say that 8 is equal to -3 times -1 plus b. And that allows for us to solve for that missing variable b, our y-intercept. We can do this because we know that the new line has to pass through this equation, -1, 8. So it must satisfy the equation. And now we just solve for b. So 8 is equal to -3 times -1 is 3 plus b. We subtract over 3. So our b is then equal to 5. So then our final equation is y is equal to -3x plus 5. All right. Once we solve for our m and our b, we then know that we have our equation. So this equation of y is equal to -3x plus 5 is parallel to the given equation of y is equal to -3x minus 5, and it passes through the points -1, 8. All right, that is it for the parallel lines, and then there'll be one more video on perpendicular lines, and then we're done for the section.